LeetCode coding challenge, and today we are going to solve our next problem statement, binary tree right side view. So let's start. Given the root of a binary tree, imagine yourself standing on the right side of it. Return the value of the node you can see ordered from top to bottom. So we have given a binary tree, and if you stand on the right side of it, you need to provide the output, the node that you see from top to bottom. So for this binary tree, if you stand on the right side, the node that you see is 1, 3 and 4 from top to bottom. And 2 got hide behind the 3 and 5 got hide behind the 4. So the output is 1, 3 and 4. Now, let's discuss the solution for this. This is you standing on the right side of it. So the node that you see from the right side is 1, 3 and 6. Now let's discuss it. How can we solve this problem statement? We can use the BFS approach to solve this problem statement. BFS means breadth first search. In BFS, we can define a queue and we can do the order traversal, level order traversal. So for each level, we will put the same level node in the queue. So if we have defined the queue and we put the node level by level in the queue. So for the first level, there is only one node, 1, and we have put our node inside the queues, right? And one more thing, queue is based on first in and first out, and we are going from left to right. We are going from left to right, and we are seeing from the right side. So for every level, we need to find the rightmost element for that particular level. So suppose for this 4, 5, 6, for this level 3, the answer is 6. 6 is the rightmost node for this level. Similarly, for 2 and 3, 3 is the rightmost node for this level. Right? So we need to find the rightmost node, and we are going from left to right. So for the first level, there is only one node, and root will always be in the answer, right? Because we see from the right side, there is only one node at the top. So we put the 1 and we find the rightmost element in the queue, and there is only one element 1. So 1 is that answer, right? For the second level, we again put 2 and 3 and we start popping it from the queue. The rightmost element in the queue is 3. So the answer is 3. Similarly, we again put the node for that particular level in the queue. So for level 3, the node is 4, 5, 6, and we need to get the rightmost node from the queue. So if we remove 4 and 5, we can find the rightmost node, that is 6. So the answer is 1, 3 and 6. So we can solve this problem statement using BFS approach, and we are going to use a queue to find the rightmost element for every level. So let's do the coding part for now and try to solve this problem statement. Delete this part. We are defining our queue of type tree node. In the years, right? So we are going to iterate on the queue till it got empty. The queue dot is not empty. We are going to iterate over our queues while the queue is not empty. Again, from the top, we need to first put our root node so that the processing can start. So offer the root node to our queue. Okay. And then we also need to build our answer. So let's define our answer list. So list of integer, answer equal to new array list. So we have created our answer list also. So for each level, we are inserting all the node for that particular level in the queue, and the most node in the queue will be our answer for that particular level. So while our queue is not empty, we can again do a while loop inside a while loop, because we are going to insert the queue level by level. While queue is not empty, do while loop. And let's define a intermediate queue also. Right. So we have offered first our the root node, and let's call it our value, our last node value for that particular level. Let's initialize it with 0. Now we first inserted the root. Now we are going to remove the value from the queue, and we also need to insert the child node 2 and 3. So we are doing it level by level. So first, remove the node from the queue, to tree node. So we have removed the first node from the queue. Then we also need to insert it. We also need to insert the child node. So we have removed the 1, but we need to insert 2 and 3. So we are going to use our intermediate node for that. So if our left side node is not equal to null, insert it into our temp node. Insert it into our temp queue. So node dot left. Similarly, if the right side child node is also not equal to null, insert it into our temp node. And at last, we are going to initialize our queue with the temp node. Right? So what is happening? We are created an intermediate queue. Then we are popping the element from our queue, right? And we are inserting the child node inside a temp queue. And at the end of the processing, we are again initializing our queue with the temp. So every time, for every loop, the queue will contain all the node for that particular level. So if it is going for the level 1, it will contain 1. For level 2, it will contain 2 and 3. And for level 3, it will contain 4, 5, 6. And we only need to find the rightmost element for a loop. So this while loop execute for one level. So this while loop always execute for the one level. So that we can find our last node also. Initialize every time our last node. Right? So suppose for this third level, first it will get assigned a value of 4, then it will get assigned a value of 5, then it will get assigned the value of 6, because queue is based on the FIFO means table, first in and first out, and we need to assign our last node that is coming out of the queue. So the last node that is coming out of the queue is 6. So it will automatically get assigned to our last node value. And this last node we can insert it to our answer. The last node value we can insert it to our answer. So yeah, we are done. And now we can return the answer. Return the answer. One more case we can handle if our binary tree is root node is null. There is no root node exists. We can return an empty list. So this is a defensive check that I have added. So we are done with the coding. Now let's run our test case. So our test case is working. Let's submit the solution. And our solution is also working. So thanks for joining the session. Let's meet tomorrow.